So, topic name is electromagnetic wave, and write notes, all of you. Electromagnetic waves. Tuhina, you did not send notes also yesterday. Tuhina, notes, your yesterday's notes, handwritten notes. I have finished it. I'll send it along with EM wave. Okay, but mention, he said these are the yesterday's notes and these are the EM wave notes because you're like everybody, parents are also observing. So this is important. So, as we understand, electromagnetic wave means in this situation you have electric field as well as magnetic field. We want to understand how they are acting together because these waves are formed by the electric field and magnetic field, how they are acting together. Example, whenever you have current, then current produce magnetic field. We studied this in magnetic effect of current. Current produce magnetic field. In EMI, we studied that the variable magnetic field, variable magnetic field will produce current. Variable electric magnetic field will produce current. This we studied in EMI. Correct? Chandana, what is the Faraday's law? That is first law and second law.
Sir, E is equals to minus N d5.
E is equal to minus N
d5 by
d by dt. It means variable magnetic flux is responsible for EMF, electromotive force. Correct? And through this EMF, you can calculate current also because here E will be equal to IR. If you want to calculate current, it will be E by R. Correct? So using this, you can calculate current. Current value will be N d phi by dt. This is your E value divided by R. Any doubt? So variable magnetic flux or magnetic field will produce your current that we studied in the EMI. Here we want to collab both of them. There was a guy named Maxwell explain this electromagnetic wave in very detail. So what Maxwell said about the electromagnetic wave? He said that there will be variation in the electric field and magnetic field vector. This electric field vector and magnetic field vector will be perpendicular to each other. Variable electric field and magnetic field vector. These two will be perpendicular to each other. These will be perpendicular to each other, and these are responsible for electromagnetic disturbance. I will write it like I'll explain this again. We are saying that we have variable electric field and magnetic field. Correct? Variable electric field will produce current. Current will produce magnetic field. Variable magnetic field will produce current again. So When you are changing electric field and magnetic field, it is responsible for electromagnetic disturbance. Means it is responsible for the electromagnetic wave. Electromagnetic disturbance means electromagnetic wave. And this electric field and magnetic field will be perpendicular to each other. Electric field and magnetic field will be perpendicular to each other. Very, very important. I will write this again. In the short, it is electric field and magnetic field will be perpendicular to each other. It will be perpendicular to each other. Okay. Next, if we see the EM wave, these EM wave move very quickly. Sarah, what could be the possible speed of the EM wave? Sarah, what could be the possible speed of the EM wave? It moves with the speed of light. 3 into 10 raised to power 8 kilometer per second. So, Ina, is this correct? 3 into 10 raised to power 8 kilometer per second. 41. Answer is no. It
Meter.
is meter per second. It is meter per second. So, Tuina, because you are new, let me know every time in every chapter or class, I will do some mistake and you have to highlight this out. Intentionally, I'll ask you, okay, this is what happened, what will be the situation. The more uh, mistake you point out, better I will feel that you are observing everything, not just writing the formulas. Okay, and this is for everyone. And when we are talking about electromagnetic wave, light itself is also electromagnetic wave. Light that is traveling is electromagnetic wave. Oh, Sarah was not here. Sarah, what did you miss?
Nothing, sir.
Nothing. Okay. So light is also electromagnetic wave because light contain both electric field and magnetic field vector, and both vector are perpendicular to each other. Both vector are perpendicular to each other. Tuhina, you were there in the magnetic effect of current when I taught this chapter. Magnetic effect of current, Ampere circuital law. Okay. So what is Ampere circuital law? What is Ampere circuital law? Ampere circuit, Chandana, what is Ampere circuital law?
So B dot DS.
Hmm. B dot ds. B dot ds. Magnetic field into your length dl, not ds. That is the Gauss law of magnetism. B dot ds.
Oh, yes, yes.
B dot dl will be equal to nu naught I net current. Correct? Inside. This was the Ampere circuital law. Why we are writing here in this chapter? Answer is this law is inconsistent. This law is inconsistent. What does it mean? It is not complete. Why? Example, if you take this Sarah, which current you will have when you use this battery symbol? AC or DC?
DC, sir.
Yes, it will be DC. And what will be the symbol of AC, Sarah? What will be the symbol of AC?
It's like an S, no, sir.
Yes, like S wave. Okay. So, example, you have these two plate capacitor. This is, let's take C1 and this is C2. Okay. So, whenever you are considering this wire, then definitely you will have current in this case. So, according to this, between the two capacitor plate, there is no charge, no current, nothing. Current should be zero, but that's not. Okay. Logically, current should be zero between the plate. Magnetic field should be zero between the plate. I will write this between the capacitor plate. This should be because there is no wire. No wire means no current. But in reality, here magnetic field is not zero. Chandana, what is the reason why magnetic field is not zero? Because current is not zero. And to explain this concept, why these are different values, we have a new topic known as, what should be the topic name, Chandana? Displacement current. Sarah, what is displacement current?
Not sure, sir.
So displacement current is produced due to change in the electric field and electric flux, and that will exist between the capacitor plate or between the plate. Like here, you will introduce a new current, that will be the displacement current. In normal wire, you have conduction current, and between the wire, you will have displacement current. Two type of current: conduction current in normal wire, displacement current in the between the wire or between the plate. Okay. So what is the reason for this? Current here is produced because of the change in the electric field and change in the electric flux with the time. Current produced due to change in electric field and electric flux with time. Right? So if we see this displacement current, then we can easily say amount of conduction current will be same as displacement current, and conduction current will be exactly same amount. Even direction will also same. Direction same as conduction current. Okay. So what does it mean? You can see here. So whatever is your conduction current, same will be your displacement current. Okay. One thing. Conduction current is equal to the displacement current amount wise. Direction. As if I take this point A and this point B. So if you are moving A to B, what is happening from A to B? There will be the direction of the displacement current. So direction of the conduction current is from A to B. Direction of the displacement current is also A to B. So we prove that key direction of both the current is same. Any doubt, guys?
No, sir.
Anybody have doubt in displacement current? Because I think in 2025 also you got a question. That's what I believe. We'll check again. And this is one of the important topic in the EM wave. Displacement current is a completely new topic. So if you understand this well, your displacement current formula will be, it is because of the electric field. That's why epsilon naught we use permittivity in this concept. And we said with the time electric flux is changing. See, the rate of change in the electric flux will give you current. Make sense? A rate of change in electric flux will give you current. Why like this? Because according to the definition, we said displacement current directly depend upon the rate of change of electric flux. When you remove proportionality sign, then you will use epsilon. You will ask, sir, why every time we are using uh, different value? Like in Coulomb's law, we were using 1 by 4 pi epsilon naught, here epsilon naught only. Answer is experimentally you prove that by doing calculation. Okay. Example, if you take one quantity, any x quantity, when your current was 1, then that quantity was 10. If you become like you make current 2, then x quantity will become 20. Current 3, x quantity will be 30. So, Sarah, what will be the constant in this case?
Sir, epsilon naught.
None. In this case, proportionality constant will be 10. The example I am giving you. Why?
Oh, okay.
Because I said ki if your current is 2, then it become 20. If it is 3, it become 30. If it is 4, it become 40. It means there is a constant number 10. You are multiplying every time. We can't tell this based on the theory. We have to prove experimentally ki when we are changing one value, how we are getting the another value. Understood? Any doubt?
No, sir.
Okay. So based on this, you can calculate, and this is important. Displacement current is a completely new concept in this case. Okay. So based on this, you can also calculate your what is d phi value. If we calculate d phi e value, then it will be current displacement current into dt by epsilon naught. Correct. And remember, even in you have to always correlate with the basic concept. The change in the charge is responsible for the current. This basic law will always applicable. Understood? And if you have both the current, like what we said here, then you will have a complete circuit. Now, Maxwell used this Ampere circuital law and he explained a Newton equation known as Ampere Maxwell circuital law. Ampere Maxwell circuital law. This law says that if you have wire, then there will be conduction current. Wire, there will be the conduction current. If you don't have wire, then there will be displacement current. Right? And based on that, you modified the law कि B dot dl total integration will be equal to nu naught IC plus nu naught IT. Ask me guys, do you have any doubt? कि earlier we were considering only conduction current. Now we are considering displacement current also. Hmm. So you can say कि this displacement current will exist only between the plate. Got it? Any doubt? Chandana,
No, sir.
Sarah,
No, sir.
Tuhina. This is conduction current and displacement current is epsilon naught d phi e by dt. Correct. So this equation is a modified form of your Ampere circuital law. So you don't need not much new knowledge, but still it's important to correlate two different concepts together. Tuhina, we know like why every time it is showing T is in the meeting group. Yes, sir. Okay, no doubt. So in a example, normal conduction current produce magnetic field. Does displacement current also produce magnetic field? Yes, it does. How normal current in magnetic effect of current we have studied. Normal current produce magnetic field. Even your displacement current is the source of magnetic field. Any doubt, guys? So displacement current is done. After that, we have four equation of the Maxwell who explain who actually used the other laws and said कि these are the Maxwell equation. He studied all the previous equation given by the different scientists and based on that he gave the law and four important equation. Maxwell's first equation is your Gauss law of electrostatic. So, Chandana, what is Gauss law of electrostatic?
So E dot ds is equals to
Hmm,
Q by epsilon.
correct. So, E vector dot ds vector area vector total integration will be charged inside by epsilon naught. Correct? Done. That was the Maxwell first equation. Second equation given by the Maxwell is the Gauss law of magnetism. So Sarah, what is the Gauss law of magnetism?
It's a BDS.
BDS. Hmm. 0. BDS in a closed loop remains 0. In a closed loop, it remains 0. Reason? Same closed surface. Any doubt, Sarah?
No, sir.
Maxwell's third equation is Faraday's law of EMI. So, Tuhina, what is Faraday's law? Tuhina, what is Faraday's law? Electromagnetic induction. What will be the formula?
Sir, can you
Tuhina,
hear
what will be
me?
the... Yes, I can.
Okay.
Hmm.
Sir, will it be epsilon is equal to minus n, that one? Minus n d
Yes.
phi by dt.
Yes.
Yes, sir.
So, if we see EMF, your EMF is equal to minus n d phi b by dt. So it means change in the magnetic flux, rate of magnetic flux will be responsible for the induced current and EMF. And
Sir,
because
can you scroll up, please? Yes, sir.
hmm,
Yes, sir, you can scroll down now.
so E is equal to minus d phi by dt, rate, rate of change of magnetic flux responsible for the electric field, and this is because of it is responsible for the current. So E dot dl vector will be responsible for this. Same Faraday's law, so nothing to bother about what we did here. Same Faraday's law. Focus on this as of now. And fourth equation is of course, Chandana. What is Ampere Maxwell circuit law?
So B dot dl is equals to mu naught into
Hmm.
DC plus ID.
Huh. So here when we are considering Ampere Maxwell circuit law, we just did in this chapter only, which say that if you take B dot dl in Ampere circuit law, then normally it is equal to nu naught IC or I, but here it is IC plus ID, conduction current and displacement current. Conduction current is same and displacement current is epsilon naught d phi by dt. So these are the four important equations. Any doubt, guys? Our
No, sir.
introduction part is done. You can check if any issue in these four equations, because these are not just four equations. These are like revision of your all the previous units, like whether you take current, whether you take electrostatic or magnetic field, EMI or AC. It's just compilation of all things because they are in synchrony with each other. Example, when you take gravitation field, you can correlate with the electrostatic field or electric field. Then electric field is responsible for the current electricity. Current is responsible for the magnetic field, so magnetism. Then change in the magnetic field is responsible for the induced current. Then you have EMI. And overall, because as of now we were talking about the DC mainly, there is a different type of current AC, right? And compilation of all these are EM wave. And that is the one of the biggest challenge for the student. What they feel ki if I don't understand one chapter, I can do other chapter easily. You can read, you can solve easy question, state formula based question, but you can't understand until unless you are really good in all the. Make sense, guys?
Yes,
Yes.
sir.
Even if you are weak in one chapter, understanding of other chapter will be really difficult. So this part is done. Now we can move to the electromagnetic wave. There are some property and many time examiner asks direct question from the properties. So example, electromagnetic wave, EM wave, EM wave. So many time what happen in electromagnetic wave, you need to know many theoretical portion, but the reality is even in the NEET not only board, they ask these questions, and I will show you questions. So first point, in electromagnetic wave, electric field and magnetic field are perpendicular to each other. We already did this, perpendicular to each other. And these two, electric field and magnetic field, are also perpendicular to the direction of the propagation of wave, perpendicular to direction of propagation of wave. Propagation means how wave is moving. So that is the thing. Ki electric field and magnetic field, they are perpendicular to each other. And second, they are perpendicular to the direction of the wave motion. Why? Because I can show you this diagram. Electromagnetic, see, in one axis above, like pink color, you have electric field. In green color, you have magnetic field. And perpendicular to this, you have propagation. Understood? So electromagnetic wave, electric field, magnetic field are perpendicular to each other. Both of them are perpendicular to the propagation also. Because if electric field is in y axis and magnetic field is in z axis, then propagation in x axis. All are perpendicular to each other. Make sense, guys? Any doubt?
No doubt, sir.
You can draw this diagram, not in the proper artistic way, just the example y axis electric field, z axis magnetic field, then propagation x axis. That's a mention axis also. And why we are writing word oscillation? Because it is going up and down. Example, in electric field, you are considering y axis up, y axis down, like positive y axis and negative y axis. Then In green color magnetic field, again plus Z minus Z like that. It is continuously changing, variable electric field and magnetic field. And then propagation perpendicular to both of them because x-axis. So in your notes, I will check these things. Give me one minute. Done, guys.
Yes.
Yes.
So first point. Second point. This electromagnetic wave, when they are produced, it is because of the accelerated charge. Charge is continuously changing its speed, because if speed is fixed, then you won't have the variable charge. Right? If it is not the variable charge, what will happen? There won't be electric field and magnetic field in the variable form. Right? So this is extremely important. I have seen this question. This EM wave is produced due to accelerated charge. Extremely important, this one. Not static or constant velocity charge. Extremely important. That's why I'm using different color. This perpendicular to each other, perpendicular to this is also important. Then, Tuhina, what will be the speed of the EM wave?
So speed of light 3 into 10 to the power 8 meter per second.
Its speed will be equal to the speed of light, and speed of light is 3 into 10 raised to power 8 unit.
So meter per second.
Yes. Next, this speed depend upon a given medium, also depend upon the electric property and magnetic property of the medium. Speed depend upon electric and magnetic property of medium. Electric property and magnetic property of the medium. Then, fifth, if you see what is the speed in the free space, Chandana, in our magnetic field chapter, what was the speed? If you take speed of light, will it be E naught by B naught?
Yes.
But if you are not calculating speed of light, you are calculating any other speed, what will be the formula? Electric field by magnetic field, because a negative sign, that's why we are taking magnitude. Sarah, energy, when we consider for the electric field and magnetic field, will energy distribution same or different?
So can you repeat the question?
I I ask you, will the energy in electric field and magnetic field same?
Yes,
Answer is
sir.
yes, because when you have both the values in the perpendicular and equal amount, only then there will be uniform distribution. So answer is yes. Energy in electric field will be equal to energy in the magnetic field. Sarah, tell me what is the energy in the electric field? In case of capacitor, half CV square energy stored in a capacitor, and in general, energy is equal to charge into potential. Right? Tuhina, if you consider inductor,
So can you repeat?
energy of inductor,
Yes,
inductor
sir.
instead of capacitor, you have inductor. Instead of
Yes, sir.
okay. So this is the main point. Key energy of electric field and magnetic field is the same. Next, Chandana, seventh. If you see energy density, what will be the energy density in both the situation? If you see electric field and magnetic field, U. What was the energy density in case of electrostatic?
Sir, of E square
Hmm.
itself.
Very good. And what will be the energy in case of uh, this magnetic field?
Sir, of P square divided by mu naught.
Very good. So guys, everything is like correlated. In one case you have electric field, another case you have magnetic field, but method more or less will be same, and we discuss this separately. If you are considering energy density in the electric field, it will be equal to half epsilon naught E square. We did this in the capacitor only. And in the magnetic field, it will be equal to half, instead of E square, you have B square, and you know, nu naught direction is like opposite to the electric field. Example, in electric field, you have permittivity in denominator, but we have permeability in numerator. So it will become ulta. Make sense, guys? Any doubt?
No,
Next, Sarah, is this electromagnetic wave charged? Answer is no. It is uncharged. EM wave is uncharged. There is no positive or negative charge present on it. That's why, being uncharged, it is not deflected by electric field or magnetic field. It is not deflected by electric field or magnetic field. Tuhina, does
Yes,
this
sir.
EM wave carry energy or momentum?
So both.
Yes, because it is wave, so it carries both energy and momentum.
So can
It
I
carry
leave with 720?
yes. We are doing last point. After that, it will be very easy. Electromagnetic radiation. You already know about that. So
So
last
because I
point.
need to eat and then
Yeah,
leave. That's it. So
got
can
it.
I
So
watch the
this
recording?
yeah. So this is the last point.
Okay.
Electromagnetic wave is the polarized. Like when you pass through the this glass, then it will be polarized. This that. So you can eat, and before leaving, you send your notes.
Sir, I'll send it right now.
Okay, good.
Yes, sir. Thank you,
Now
sir.
you can. Okay. Any doubt? Chandana and Sarah,
No,
in
sir.
these 10
No.
point are these 10 point are extremely important. Read this again carefully and ask me your doubt.
So can you explain the last point?
I will explain this in more detail, Sarah, in wave optics,
Okay.
where we have the topic of polarization. When you have unpolarized light, it means it is moving in all the direction. Okay, that is unpolarized light. And you pass through special prism, Nicol prism, then it will shift into the particular direction, and you will call this light as a polarized light. Light is moving in a particular direction. Any
Understood,
doubt?
sir. No, sir.
And remaining thing is how if we change the glass angle 90 degree, 0 degree, how light will polarize and polarize. That's a different scenario. But in the shorter form, same thing we did in the chemistry also. Okay, if you have any unpolarized light, in this it is moving in all the direction. So this is unpolarized light. When it passes through a given medium, unpolarized light. When you pass through a prism or any special glass, so what will happen? It will become polarized and light will be available in a particular direction. This light is known as plane polarized light or polarized. Understood? So
Yes,
this
sir.
can be polarized. So if you are done with it, we can do the easiest part of this chapter because you already know. So I will ask you mostly electromagnetic spectrum. So, Sarah, what is this electromagnetic spectrum?
The dispersion of light,
No, spectrum, range,
like, um,
electromagnetic spectrum.
so like when white light passes through prism, we get a spectrum of
That is
set.
the spectrum of light. This is electromagnetic spectrum.
Oh,
You have gamma rays, then you have X rays, then UV rays, ultraviolet, then visible, then infrared, microwave, and last, radio wave. Any doubt, guys? So these are the total seven radiation in the electromagnetic spectrum. We arrange this in the order of the frequency. Example, if you go down the group, then here frequency will decrease. It means gamma rays have maximum frequency and radio wave have minimum frequency. Okay. In gamma rays, you will have minimum wavelength, and here you have maximum wavelength, and it means down the group wavelength is increasing. Any doubt, guys? Sarah?
No, sir.
Hmm. So frequency decrease, wavelength increase down the group. What will be the impact in energy, Chandana?
So radio
If you
wave has smaller
energy, what will be the impact in the energy? Increase or
energy
decrease?
increase.
In decrease. Why? Because you know energy of this wave, energy E is equal to h nu, correct? So through this, energy is directly proportional to the frequency. So if frequency is decreasing down the group, automatically your energy will decrease. If frequency decrease, energy decrease. Any doubt?
No, sir.
Let on let. And then why wavelength? Because you know your free hc by lambda. So it will inversely proportional to lambda. Okay. So this is the reason why directly proportional to the frequency and inversely proportional to the wavelength. Okay. Then Chandana, what will be the intensity of wave? We already did this. Chandana, what is the intensity of the wave? How much energy do you have in, per unit time, per unit area? It is also look like power per unit area. So intensity in general is important, and we discuss this in many discuss in the wave chapter also. Okay, so whenever you will calculate intensity, always correlate power by area or energy per unit time per unit area, because power is equal to energy per unit time. So using this equation, if you see speed of light, what will be the formula, Sarah? Correct?
Yes.
T is the speed of light, and V is the speed at any other situation except this. Right? So even in this, when you are calculating intensity, you can calculate in the different version. Example, if you know you are calculating energy, Chandana, what will be energy formula in the related to electric field? Half epsilon naught E square, because we try, like we sometimes forget this, correct? You know U is equal to this, but energy we have to write in the energy form. Any doubt, guys? So this energy is also equal to power into time. Then you say that your electric field is directly depend upon the under root of power, where E is not energy but electric field and P is the power. Understood, guys? Is it easy? Because I think I have seen one question, so that I thought I should introduce this part. Relation of electric field and power. Because let me ask you, Chandana and Sarah, did you solve any question where you did this equation electric field is directly proportional to under root P, or you did this equation in general? Forget about the question. Chandana.
No, sir.
So that's why most of time we ignore this topic. We don't know. In future, it might be asked. So that's why last, like our chapter is already done. Last thing is wavelength, and based on the frequency, nu. Based on that, you are comparing different type of electromagnetic radiation. Example, first gamma rays. Second, Sarah, what will be second one after gamma rays?
Sir, X-ray.
Very good. X-ray. Chandana third,
Sir, UV ray.
UV ray. Sarah fourth,
Visible.
visible. Chandana fifth,
Sir, infrared.
infrared. Sarah sixth,
Wave.
microwave.
Microwave, sir.
Chandana seventh,
Radio wave.
radio wave. So these are the different type of wave. So though this number is not so important, but the reason why I am introducing this is in one of the year, I think in 2016 or 17, they asked directly. Ki wavelength was given, I guess. Ki which region it belong to, gamma, X-ray, UV, like that. So in gamma rays, wavelength will be minimum. So wavelength will be less than 10 raised to power minus 12 meter, and frequency will be maximum. So it will be way too much, 10 raised to power 20 to 10 raised to power 23 range. So frequency maximum and wavelength minimum. If you take here wavelength, then it will be more than 1 millimeter, and this will be very less, 10 raised to power 11. Okay, 10 raised to power 11. So almost you can take difference of 3, more or less you can take difference of 3, and then you can compare. Example, first one was 10 raised to power 20 to 23. Next one, 3 less, it will be 17 to 10 raised to power 20. Next will be 10 raised to power 14 to 10 raised to power 17. Here visible is very popular, around 10 raised to power 14 hertz. Correct? This is very popular. Now reduction will be slow down, like 10 raised to power 13 to 14. This 10 raised to power 11 to 10 raised to power 13. Again, range you have to take it 2 to 3 difference. So they can ask range, like which one belong to which. And if they give the exact key 10 raised to power 14, it will be difficult for you to tell, because in UV, visible, and infrared, all three can have in the range of 10 raised to power 14. Here, I'll make easy. Key 10 is less than 10 raised to power minus 12, 10 raised to power minus 8, 10 raised to power minus 7. Here, this is very popular that from 400 to 750 nanometer specific range we will use in the other chapter also. Correct? Even in our photosynthesis chapter, then this will be in the micrometer 10 is to power minus 6. This will be in millimeter, and this will be even more than that. Remember, wavelength is increasing and frequency is decreasing. No need to remember this data, you have to compare the data. And guys, finally, chapter is over. Done. That's all. Electromagnetic wave.
Yes, sir.
So only one chapter is left, that is optics from class 12. So you need break for 10-15 minutes and then we continue with the questions.